Okay, this is lesson 8 of module 4. We're still working on linear equations, and this lesson is titled Linear Equations in Disguise. So we'll be working with linear equations that don't necessarily look the same as what you've been working on. So this linear equation here is two ratios that are set equal to each other, and we have a name for it. It's called a proportion. A proportion is when we make a statement about the equality of two ratios. So when we have an equation like this, there's some special things that we can do. So one thing I can do with this is I want to get x by itself. So if I multiply both sides by 5, I'm going to get x is equal to 6 times 5 over 12. Okay, so I could solve that, but I want to show you something else. So now what I'm going to do is multiply both sides by 12. When I do that, I get the 12 canceling out here, and I get that 12x is equal to 6 times 5. Okay, so I get this new equation here, and that might look familiar to you because when you look up at this original proportion up here, just this right here that we started with, notice maybe you remember when we've been setting cross products equal. That's what I get immediately if I go to here. 12x is equal to 6 times 5. So what we'll be doing in this lesson is doing that directly. But first, let's go ahead and finish solving this one. So if I go back a step, I can see that x is equal to 30 over 12, which can be simplified. To dividing top and bottom by 6, I would get 5 halves. So x equals 5 halves is a solution to this equation. But what we showed is kind of more generally, if we have a proportion, and I'm just going to use letters to stand for these parts of these ratios, we know if this is true, then A times D here is equal to B times C here. So these are going to look like the linear equations in disguise that we're talking about. This will look more like the linear equations that we're solving. All right, so let's look at the first example. These examples are going to be a little bit more complicated, but we'll see that they are just linear equations that we can work to find a solution. So we're going to assume that there's some x that will make this true, and I'm going to use that multiplication property of proportions to solve it. So I'm going to start by putting parentheses around this because I need to think of x minus 1 as a factor and x plus 1/3 as a factor. So when I rewrite this, I can write 4 times x minus 1 is equal to 2 times x plus 1/3. So I just use that, a over b equals c over d. Then, the a times d is equal to, is, oh, shoot, sorry, it doesn't like my hand down here. Having a hard time right now. Okay, sorry. Is equal to B times C. Okay. So that's all I did. I just set the cross products equal to one another because that's what's true of every fraction. So now I have a linear equation, but I'm going to need to use the distributive property to solve for x. So I'm going to go ahead and do that. So if I distribute the 4 into this, I'm going to get 4x, just 4 times x, minus 4 times 1 is equal to 2x. So I'm going to multiply the 2 into this. 2x plus 2 thirds. All right, and so continuing on to solve this, I'm going to choose to subtract 2x from both sides of this equation, which gives me, left on this side, I will have 2x. 4x minus 2x is 4 minus 2x, or 2x, and then I still have minus 4, and that equals 0, because 2x minus 2x is 0, plus 2 thirds. 2x minus 4 equals 2 thirds. So let's continue on the next page with that. Okay, so what I can do now, solving this equation, is use the addition property of equality and add 4 to both sides. So that leaves me with 2x is equal to 2 thirds plus 4. So I'm going to go ahead and rewrite 4 so that I can add it here. So 4 written as thirds is going to be 12 thirds. And the way I do that is multiply by 3 over 3 and get 12 thirds there. And remember, multiplying by 3 over 3 is just multiplying by 1, so it doesn't change it. But that's not times there. This is plus. 2 thirds plus 4. So 2x is equal to 14 thirds. So to get x by itself, I'm going to, I divide by 2, but since I've got a fraction over there, I'm going to think of that as multiplying by 1/2. So 1/2 times 2 is 1x. So I've got x is equal to 14 thirds times 1/2. And I'm going to simplify this before I multiply because there's a factor of 2 in the 14. So x is 7 thirds. And that will be the unique solution to that equation. And we will want to go back and check that. So let's go back there. So to check that, I'm gonna have put 7 thirds in for x. So I'd have 7 thirds minus 1, which I'm going to write as 3 thirds, over 2. And I'm just trying to verify that these are equal. And so I'd have on this side, I've had 7 thirds plus 1 third over 4. So over here I've got 4 thirds divided by 2, and over here I've got 8 thirds divided by 4. So I can think of this as, I'm going to go ahead and change the divided by 2 to times 1/2. Just because I'm running out of space here. And divided by 4 would be times 1/4. That cancels there. This cancels here, and I get that 2/3 equals 2/3. So it does check out. X equals 7/3 is the solution to this equation. Okay, our next example looks even more, a little bit more complicated, probably because of this fraction here, the 1/5. But we're going to solve it exactly the same way. So I'm going to start by setting the cross products equal. So I'm going to have that 3 times 1/5 minus x is equal to 7 times 2x plus 9. Okay, and that's not magic, that's just a shortcut for, it just cuts a couple steps out of the solving process, as we saw in that very first opening example. Okay, so let's go ahead and use the distributive property here on both sides of this. Now, one of the main causes of errors in this is forgetting the parentheses, not writing the parentheses maybe, and then forgetting that that 3 is multiplying everything on the top of that fraction here in the numerator. Same thing with the other numerator. 7 doesn't just multiply the 2x, it multiplies the 2x plus 9. So both of those things have to be multiplied. So that's a real common error that gets made. So let's look here. So we would have 3 times 1/5 is just 3/5 minus 3 times x, which is 3x. And on the right side, 7 times 2x will be 14x. And 7 times 9 is 63. So that's our new equation there. And now we can start using the properties of equality to get x by itself. So I'm going to separate my left and right side so I remember to do the same thing to both sides. So a good first step for this would be to add 3x, get rid of that negative x coefficient. So add 3x to both sides, and when I do that, I get an equivalent equation. The minus 3x and the plus 3x becomes 0, so I'm just left with 3/5. Let's write that in purple. Just left with 3/5 on the left is equal to, and I'm going to add the 3x to the 14x and get 17x, and then I still have plus 63. Okay, so let's continue on with this. Okay, and we know from lesson 7 this is going to have a unique solution, but it does look a little messy. So I'm going to, next step, I'm going to take and subtract the 63 because we want to get the 7x by itself. So we're going to have 3/5, and I'm going to show my minus 63 is equal to 17x plus 63 minus 63. Okay, so this right here becomes 0. So I've got 3/5 minus 63. So I want to write 63 as fifths. So I'm going to need to take 5 times 63. So 5 times 60 is 300. 5 times 3 is 15. So this is 315 fifths. And that is all equal to 17x. So let's straighten that out. So 3 minus 315 would be negative 312 fifths is equal to 17x. And now we'll multiply by 1 over 17. Now notice I'm choosing to multiply by the fraction rather than divide by the whole number, just because I've got another fraction over here. Okay. And since 17 is not a factor of 312, I can just rewrite this fraction here as negative, let's write it in purple, negative 312 over 5 times 17, which is 50 plus 35, which is 85. And that will equal, over on this side is just my x variable because the 17s are canceling. So I just got x equals negative 312 over 85. Okay, so we could go back to the original equation and our solution was x is equal to negative 312 over 85, and we could substitute it in here and check it out. Okay, so I could ask you, is this a linear equation? And the answer would be yes, because it's two linear expressions set equal to each other. Okay, so let's keep going. This next example you have in your notes, so we'll go to it there. Okay, so this is example 3 in your notes for lesson 8. Can this equation be solved? 6 plus x over 7x plus 2/3 is equal to 3/8. Well, if you think about this in terms of just writing the cross products, then you can see that it probably can be solved, because we can write the cross products as a new equation. So we would have 8 times 6 plus x, taking the cross product that way, is equal to 3 times 7x plus 2/3. Okay, so that gives us a new equation that's equivalent to that. I just want to fix that. That's equivalent to that original one. Okay, so once again, the most common error is to forget the parentheses and to only multiply that first part of the numerator by the denominator. Okay, so 8 times 6 is 48. 8 times x is 8x. And on the other side, we've got 3 times 7x for 21x. And then we've got 3 times 2/3, which is just 2 over here. So I've got 21x plus 2 here. And remember, I didn't draw my arrows, but I'm doing this. I'm multiplying each term inside the parentheses by the term out front. Okay, so we have a new equation here. And we can start using the properties of equality now to straighten this out. So let's look at that. So I'm going to choose to take and subtract 8x from both sides of this equation. And the reason I'm doing that is to keep the coefficients positive. It's just a good habit, but it's not necessary. You can do it however you want. I'm going to keep it straight by drawing my line. So 8x minus 8x is 0. So I'm left with just the 48 on this side equals 21 minus 8 would be 13x. And I still have plus 2. All right, so I want to move the 2 over to the other side by subtracting it. And I get 48 minus 2, which is 46, is equal to 13x. So I'm going to continue up here. So 46 equals 13x. So I want to divide both sides of that by 13. And I get that x is 46 over 13. That's my solution there. Okay, here's example 4. Can this equation be solved? Same way we did the other ones. We're going to take the cross products, so I can see that 1 times 3x plus 9, which is just 3x plus 9, right, is equal to 8 times 7, which is 56. And so let's rewrite this. So 3x plus 9 is equal to 56. All right, this one's going to be a little more straightforward. Subtract 9 from both sides. And I'm getting closer to a solution. So this is 3x is equal to 56 minus 9, which is going to be 47. All right, and then my last step here would be to divide by 3. And straightening that out, I get 3x divided by 3 is just x. 47 divided by 3 is 47/3. Okay, now we're going to look at an example where these types of proportions come up as linear equations. And similar triangles is a great example. So we have two similar triangles here, ABC and A prime, B prime, C prime. Using what we know about similar triangles, we can determine the value of x. Okay, so what we know all the angles are the same, but we know that the corresponding side lengths are proportional. So we can write a proportion that expresses that. And so let's do that. So we want to determine the value of x. And so we've got expressions for these side lengths, AB and AC here. And so we're going to set these up. So side length AB is x minus 2. And that corresponds to side length A prime, B prime, which is 9.5 centimeters. Okay, so that ratio is going to equal the ratio of AC to A prime, C prime. So I've got x plus 2 corresponds to A prime C prime, which is 12 centimeters. So there's a proportion we can set up from this. Now, there are many different ways we could write this, but they're all going to end up giving us the same result for x. Okay, so what we want to do now is, of course, multiply the cross products so I can have an equation that I can solve. So, and remember, we want to not forget to put these things in parentheses. 12 times x minus 2 is equal to 9.5 times x plus 2. Using the distributive property, we end up with 12x minus 24 is equal to 9.5x plus 9.5 times 2, which is 19. So we end up with this new equation to solve based on these similar triangles. Okay, so I'm going to come over here and do that. Okay, so I've got this new equation over here, and I'm going to start by adding that 24 to both sides, working on getting x by itself. So now I've got 12x, because the other part became 0. 12x is equal to 9.5x plus 43. All right, so now I want to get the x on the other side, so I'm going to subtract 9.5x. That's going to become 0 over here, minus 9.5x. And so 12 minus 9.5, well, 12 minus 9 is 3, minus another 0.5, so this is going to be 2.5x is equal to 43. Okay, and since this problem, these answers are in tenths of a centimeter over here, I'm going to express my x in tenths of a centimeter. So, sorry, I have to come over here. So x is going to be 43 divided by 2.5, which is approximately 17.2. Okay, so we were just asked to find the value of x, but we could use that value of x of 17.2 right here to find the side lengths now. So let's clean this up. So if x is equal to 17.2, then the length AB would be equal to 17.2 minus 2, or 15.2 centimeters, and length AC would be 17.2 plus 2, which would be 19.2 centimeters. Okay, now let's go to the exercises here. Let's see, the directions say solve the following equations of rational expressions. That's what these technically are. This is a proportion, but they're ratios, so they're rational expressions. Solve for x if possible. Okay, so you can work on exercises 1 through 4 independently, and then check your answers either at the end or one by one, your choice, as you go through. Okay, and I will solve them here. So go ahead and pause now and work on that. Okay, here's the worked out solution for exercise 1. I'll just quickly run through it. We set the cross products equal, so 6 times 2x plus 1 and 9 times 1 minus x. Distributed that out to get the next step here. And then I chose to add 9x to both sides to get 21x plus 6 equals 9. Subtracting the 6 to get the x term by itself on one side. So 21x equals 3. Divide through by 21. And I get x equals 3 divided by 21, which is 1/7. Okay, and I could take this 1/7, put it back up in here for x to check my answer. All right, so I'll do exercise 2 next. So pause the video if you have not already done this one. Okay, so here's the solution for exercise 2. So this first step here is just the cross product set equal, remembering the parentheses here. So, and this next step will be distributing. So 7 times 5 is 35, 7 times 2x is 14x, and the same thing over here, multiplying by 6. So I chose to add 6 to both sides. Could have done it a different way, of course. And then subtract 14x. Dividing gives me x is equal to 41/4. Okay, so you can look at that a little longer if you need to. We'll go on to number 3. Okay, here's the worked out solution for number 3. So again, set the cross products equal. 3 times x plus 9 is 12 times the quantity negative 2x minus 1/2. That gives us this equation for the next line. 3 times x and 3 times 9, 12 times negative 2x, and 12 times 1/2, which is 6. So I chose to start off by adding 6 to both sides, which gave me this next equation. 3x plus 33 is equal to negative 24x. This, of course, became 0 over here. Then I needed to get this x term away from here and over to here. So I subtracted 3x from both sides. And 3x minus 3x is 0 here, plus 33. And then over here I've got negative 24 and negative 3x. So this is negative 24 minus 3, which is negative 27x. Okay, here's where your using integers really comes in, and you have to understand what's going on here. I'm either adding a negative 3x or I'm subtracting 3x. So think of that on the number line when you do those. All right, so next then I just divided by negative 27 so that I could get x all by itself here. This became 33 over negative 27. There's a common factor of 3 in both of these. So 33 divided by 3 is 11. 27 divided by 3 is 9. And this is a negative that we'll bring out front of the entire number. So x is negative 11/9. Okay, one more, and then you'll be ready for the problem set. So go ahead and pause it, do exercise 4, and come back and check your answer. Okay, so here's the worked out solution for exercise 4. So we started with, again, the cross products here, and using the distributive property, we end up with 16x plus 2 equals 15 minus 20x. And that's just multiplying each of these terms into these parentheses. Okay, so at this stage, I decided that the easiest thing to do would be to add the 20x. So I did it, add 20x to both sides. So adding the 20x and the 16x, I get 36x. Okay, some people, I should mention, are still trying to add things like 20x plus 2. Those can't go together because the 2 is a constant term and the 20x is a variable term. So they can't, there's no way to use the distributive property to put those together. I can only do that with if they both have the same variable part, because I can factor it out and use the distributive property. Okay, so anyway, so I get 36x plus 2 is 15. Subtract the 2 from both sides to get the 36x by itself. I get 36x is 13. Divide by 36. And that gives me x is 13 over 36. Okay, so you are now ready for the problem set. But before you go on to the problem set, and of course you're going to do the exit ticket as well, you might want to take a little bit of time and read over this lesson summary here, which will kind of summarize what we were talking about and how we dealt with these proportions by setting the cross products equal. Okay, good luck with that, and we'll see you back here for lesson 9.